All right, so Project Huge Lithium Welding Battery has begun. So I ordered a bunch of these Headway 38120 HPs, which have a really high current rating, and each of these cells is 8 amp hours, and it's lithium iron phosphate, which is probably the safest lithium chemistry that I'm aware of anyway. So yeah, these cells are pretty huge. And other people have done a bunch of interesting experiments with these, like melting wrenches and stuff by pretty much short-circuiting them. So yeah, I just figured building my own battery would be better than getting lead-acid deep cycle batteries, and a lot better than using the jump starters that we tested with before. So the goal is to do a 24 volt pack to start with, and it'll be 8S 4P for 32 amp hours. So all these cells I got are used cells. I got them by the 4-pack on eBay. So I need to charge them all up and then measure the capacity and the internal resistance, so I can pair similar cells together when I put them in parallel. And any duds, I can throw them out. Or my plan, since I got 4 extra, was to take the weakest 4 and then maybe make a motorcycle battery out of that or something. So yeah, I've got my iMax B6AC smart charger over here on the left. It's charging up 1, and then I've got my 4 cheap Wenpatech power supplies charging 4 more. So I guess my plan is going to be to charge them all, and then I'll use the discharge measurement function on the iMax to measure the capacity, and then I'll write that on each battery so I can refer to it later when I'm building them up. Slight change of plans. I ended up doing a 12S 6P battery pack instead. So it's nominal 36-ish volts from end to end and 6 in parallel. So it should be more than enough voltage to run the Ready Welder spool gun at full power, and it should be useful for other things too, like running an inverter. So what I did here was I got some 1/4 inch thick by, I think this was 2.5 inch, something around there, 6101 aluminum bus bar material. And yeah, so I got a bunch of that from Online Metals, cut it, and used a benchtop mill to do the hole pattern. And all these connectors here are Dents, I think they're Dents 35s. Can't remember exactly, but these are the larger dents that are common on 200 amp class machines. So Dents quick connects. So these came out of a bunch of panel connectors I got on either Amazon or eBay, and I took the shroud and the nut off of it, and I milled a slot in each of these so that it would fit real tight over the bus bar. And then I used Al Solder 500 to solder these brass connectors onto the aluminum bus bar. And that stuff just worked great. We can focus here. Yeah, it flowed in nice, made a really nice connection. I only soldered one side, and then which flowed into the end. I didn't bother to flip them over and solder both sides. I figured between the mechanical connection from having to tap them on with a hammer and then the solder on one side, I figured it was plenty strong enough. So this is turning out to not be the lightest battery pack in the world, from all this metal from the bus bars, and then the fact that each one of these cells has a pretty stout metal casing on it. But this should be good for quite a bit more cycles than a deep cycle lead acid battery. So the plan now is to build a box for it so I can safely move it around and stuff. And yeah, then test it out. So after I got done assembling this thing, I kind of got scared of it, because any type of short in here and it'll just, it'll dissipate massive amounts of power. I mean, I think I accidentally welded part of a wrench or a pair of scissors when I was putting this thing together, just from accidentally, you know, touching two pieces of metal together there. And the voltage is not real high between here, but the current capability is huge. So my temporary solution was some thick electrical tape between here, just to help protect, you know, and not rely just on this thin sheet of plastic on each cell. And then after that, I ordered some polypropylene sheet. This is about a 1/16 of an inch thick polypropylene sheet, just for extra insulation. So I'm gonna install these between each set of cells, and that way I can feel safer about it when I'm moving around, charging it, things like that. And just for grins, here's the Viking jump starter pack and an 18650 lithium for scale, just to kind of put it in perspective. And here is the finished product. This is the 12S6P lithium iron phosphate battery in a case. And on the side I have a 3 kilowatt pure sine wave inverter. And there's 3 cell meters, I guess you could call them. They will display the voltage of the whole pack that it's connected to, as well as each cell. And you could set warnings on there. So you can tell it what type of battery chemistry you're using, and it will start beeping an alarm if any particular cell voltage goes too low, which is good for knowing when to stop and recharge. So all in all, it weighs about 75 pounds, which is quite a bit more than I originally anticipated, but that's still less than half the weight of an equivalent capacity deep cycle lead acid battery. And this should be good for many more deep cycles than lead acid would be. And over here, I converted the ends of the Ready welder to dense quick connects instead of the Anderson power connector and jumper cable style clamps that were on there originally. So this allows me to roughly choose the Mig Welding Voltage by just choosing which connector I'm using up here. So I'll be using Flux-Core 035 steel wire, and I'll be running electrode negative, and undecided on the voltage. I'll probably be somewhere around 20 or 24 volts to start out with, just for some testing.
So this is 1/8 inch thick material, and it's around 23 volts and 200 amps. And I mean, not my prettiest MIG weld, but plenty enough to prove out the capability of the machine. I'd really like to get some 045, some thick stuff, and wind it onto one of these small spools so I can try it at a higher voltage, higher power. But I think you need gas cooling for that to work properly without overheating the spool gun. So, pretty happy so far. And I think next I might try to run a small 120 volt welder off of the inverter, see how that goes.